All right, take a look at review day 5. So we're talking about graphing equations of lines here today. So two types of equations to talk about are slope-intercept form, which is y equals mx plus b. So remember the m, like mountains, you got a slope, and b, where we're going to begin with the y-intercept. So to graph it, we're going to begin with b. So plot a point on the y-axis where the graph is going to cross. We're going to use the rise over run, the slope, to make more points, and then we're going to connect those dots to form a line. All right. When we look at a line from a graph, if we have to interpret it, we can always count the rise and the run by telling how to get from one point to the next. So for example, if I want to move from this red point, I'm going to travel up a certain amount of units and over to the right. So up is a positive direction, right is also a positive direction. So I know that I'm moving positive and positive. So my slope is going to be positive. So I'm going up 2 and then over 3 to the right. So in terms of the rise over run, I can interpret this graph as having a slope of 3 over 2. And the y-intercept is located, all right, at -1 on the y-axis. So that I know that my y-intercept b is -1. So that's how I can read the equation from the graph. So we're just taking a look at a couple of these. We're going to graph them. So for number 28, I want to indicate what my slope is. It's -3 over 2. My y-intercept is 2. So I'm going to go up 2 and plot a point. And then I'm going to use my slope. So since it's -3 over 2, I either have to move down negative and right positive, or up negative or up positive and left negative. If I do a up, if I go down and left, that's two negatives. Remember, we divide two negatives and make a positive, so that's actually a positive slope. And if I go up and right, that's also a positive. So if it's a negative slope, you're going to have to move down and then right. So down and right is going to put me at the point 1 negative or 2 negative 1. So right there. And then I can do the same thing again if I want. I can move down to 3 and right 2. And there's my next point. Or I can go up 3 and left 2. All right. You will have a ruler on the exam. For me, for purposes that I'm doing this, a ruler is just anything that makes a straight line. So your bus pass, you won't have that on the exam. You don't need that. You'll actually have an actual ruler. But in terms of things you could use if you don't have one, an index card, the side of an index card, a bus pass, anything like that. And we want to extend the arrowheads at the end of the line to indicate it's going on forever. And then we would want to indicate our equation by labeling it. Y equals -3 over 2x plus 2. All right. Technically, in terms of purposes for the exam, the line just needs to cover the entire graph. And as long as there's only one function on the graph, only one type of that function, so a linear equation, a line, one parabola, one absolute value, you don't have to label it. But I would get in the habit of doing it because if in the event you have more than one and you forget, you will lose a point. All right. For each graphing area, you lose a point. So here the slope is, for 29, the slope is 1, so 1 over 1. The y-intercept is -3. So I'm going to go down 3, put a point, okay? And then I'm going to move up 1 and over 1 and put some more points here, all right? That's all we're doing to graph this line. So up +1, up and right, or down and left. And then we can just extend our line to cover here. So this is going to be the slope we're looking for. So these are the droids we're looking for. All right. And then this is going to be y equals x minus 3. And then the last one, we're going to do the same concept here. The slope, the y-intercept is going to be 5. The slope is 1/3. So we're going to move down 5 on the or up 5 on the y-axis. 1, 2, 3, 4, 5. Put it first dot. Okay. And then our slope is 1/3. So I can't go up, so I have to go down. And if I'm traveling down, I have to go left to keep this as a negative quantity. So down 1 and then over 3. And then my graph should look like that. That's all I can fit on here, guys. So it's going to look like this. Okay. And then y equals 1/3 x plus 5. So I know it's an increasing slope. It's positive because as I go from left to right, it goes up, like going upstairs. Okay. The other type of graph we're going to take a look at is standard form. So in standard form, A, B, and C are given, and A and B are essentially just the intercepts on the x and y axis. So the A is never going to be negative. We want to keep it positive. All right. So if you're going to graph, we want to find both the x and y intercept essentially by plugging 0 in for y. And then at that point, we're just going to put points there and then connect the line. So if I'm looking at a graph and I need to write it in standard form, I'm just going to look at what the x and y intercepts are. So the x-intercept here is essentially negative. The y-intercept is 2, and the x-intercept is negative 3. All right, and then we're going to just graph that accordingly. So if you notice, the intercepts, if we take a look at 31 here, okay, if I want to find the x-intercept, I'm plugging 0 in for the other letter. So for 2x minus 0 is equal to negative 2. That means if this is just going to give me 0, so this is just 2x is equal to negative 2, okay? And then I divide by 2 to get x is equal to negative 1. So at negative 1 on the x-axis, I'm going to put a dot. And then if I have plugging 0 in for x, 2 times 0 minus y is equal to negative 2. That means 0 minus y is equal to negative 2. And if I divide by negative 1, I'm going to get y is equal to positive 2. So at y at positive 2, okay? And then we're just going to draw a line going up in that direction and down in that direction. All right? Now we could interpret this as y equals mx plus b because we have the y-intercept. Oh, good job. And the slope is 2. We have a savior over here, right? The slope is going up 2 and over 1, so the slope is 2. We could interpret that, but that's essentially how we're going to graph. Your other option is just to solve for y. So if I did that, we would get 2x minus y is equal to negative 2. So we would move the 2x over, okay? So then we're going to get negative y is equal to negative 2x, and then this is minus 2. So sorry for that. You can't see the minuses there. And then when we divide by negative 1, we can then just graph this line as is. So this is 2x plus 2. So graphing a plus 2 put me right there, okay? And then we're going to graph the slope of 2. So we're going to go down the left, down 2, left 1, and keep going on. Same thing here. I could subtract the x from both sides. I come up with an equation. And remember, one tip here is always try to put the x first because that's in y equals mx plus b form. So it's a little easier to read. So my slope is negative 1. My y-intercept is 4. Also, if I plug 0 in for the other letter, we'll see the x-intercept is 4, the y-intercept is 4, and then we can just graph accordingly. But if I put my y-intercept at 4, and then essentially just using a slope of negative 1, which means I'm going to go down 1 and then right 1. So down 1 and then right 1 will put me here, down 1 and right 1. That's not what we wanted. Okay, and you'll see we'll end up at a x-intercept of 4 anyways. So we're just going to draw that line in for ourselves. The magic of technology. Okay, we'll throw some arrowheads on. Some appropriately sized arrowheads, if you don't mind. And then we label x plus y equals 4. Okay, see if you guys can try the last one. Let's see if you guys can get it right. All right, so we can see if you plug 0 in here for x, we're going to get 4y equals negative 12, and then y is going to equal negative 3. So that's going to be our y-intercept. So we can drop over there and put a dot. And if we divide by 3, if we plug 0 in for y, we're going to get 3x is equal to 12. So we'll get x is equal to negative 4. So we have one intercept right here for ourselves. Need a little bigger dot here. Okay. And the other one's at negative 4. And that's what our line would be. Your other option, like we said before, is to essentially solve for y. So we subtract 3x from both sides. Put the x in front. So 4y equals negative 3x plus 12. And then divide 3 by 4. And we're going to get y is equal to, oh, this should be, whoops, we got an error, right? This shouldn't be plus 12, it should be minus 12 because it was minus up here. So we want to make sure that's a minus 12. So minus 12. And then we're going to get negative 3 over 4x minus 3. So our y-intercept is negative 3. And then our slope is going to be essentially up 3 and then over 4. Because remember, it's positive 3, right? If we move in a positive, then we have to move in a negative direction. And we're going to find that next point there anyways. All right? So either way you solve it, you should get the same answer. And we can go ahead and graph our line. All right. Arrowheads. Equation. You can always just put down the equation they originally give you, and that's fine. All right, so there's the first page. On to the back. So point slope form, essentially the same thing. At point slope form, it looks like the slope formula we talked about yesterday. So m is equal to y2 minus y1 over x2 minus x1, except what we're essentially going to do is just cross multiply. Okay, so I get y minus y1, where y1 is one of the coordinates for the y that they give us, equals m times parentheses x minus x1, where x1 is the point they're giving you. Okay, so x1, y1 is a point on the graph, and m is the slope. If you want to convert it into y equals mx plus b, just distribute the m and then move that y1, this is a y1 here, to the other side of the equation. Okay, in the standard form, bring the x term to the left side, all right? And if there's any fractions in the equation, just multiply through by the LCD, okay? And if a is negative, make sure you change all the signs. If we're given point slope form, you can just read the graph, right? So I can read the graph. I can remember this is supposed to be y minus y1 equals m parentheses x minus x1. So just like when we did transformations, this is supposed to be a minus here, but it's actually a plus. So that tells me the x coordinate is actually has to be a -2, right? It's got to be minus -2. So this point is -2, comma, and same thing. This is supposed to be a minus, but it's actually a plus. So the y coordinate is -3. My slope is 1/2. So I can actually go plot this point, -2, -3. So I'm going to go left 2, down 3. There's my point. And my slope is 1/2. So I'm going to go up 1 and over 2. Up 1 and over 2, down 1 over 2 to the left. And then that's another way that I can just graph using the point slope formula. When in doubt, right, just multiply through and get these as y equals mx plus b. And then you should be good to go in that regard too. So keep that in mind in terms of what we're doing here, that you can always get it in solve for y and just be able to graph that way. All right. Pen size. Here's my graph. And then if we're going to distribute, okay, so we would distribute the 1/2. I'm going to write it down here. So y plus 3, and after I distribute the 1/2, I'm going to get 1/2 x and essentially plus 1. So I'll minus the 3 to both sides, and I'll have my equation. Y equals 1/2 x minus 2. So we can see we would graph with this, and there's our slope of 1/2. So my graph is going to go there, and I can find my next point by using that slope. So it's the same thing. So when I state the equation, I can either write the slope-intercept form, 1/2 x minus 2, or I can write the original equation they gave me. All right, see if you can try the next one. All right, hopefully you figured out that we were using the point 3,1. So the y-coordinate is +1, the x-coordinate is -3 to make that happen. If you didn't, you could have distributed through and gotten the equation y equals 2/3 x and then adding that over -1. So we're just going to go graph at -1, use a slope of 2/3, okay, down to left 3, and then we can draw our graph in here. All right. Did it again, people. All right. And so there's my graph. And then I can do the same thing. So y equals, or actually we can just put down the original equation they gave us. And we're covered. All right, and the other one, it's y minus 2 is equal to 0. So if you basically added this over to get y by itself, you're going to get y is equal to 2. And all the points where y is 2, it's essentially all the points like 0, 2, 1, 2, right, 2, 2. So it's basically just this horizontal line right here. All right. If it's x equals 2, it should be all the points where x is equal to 2. So it's actually a vertical line. So just keep that in mind for yourself. All right. The other questions we're going to be dealing with are forming equations, where we're going to have to use our word problems. So remember verbal phrases for plus, addition, like for plus, for addition, sum, plus, added to, more than, greater than, less than. Remember, the more than means that it actually comes after. So if I say like 3 is more than a number, or a number, we're going to add 3 to that. Or if I say 3 less than a number, that would mean that it's the number x and then take away 3 at the end. So if we see more than or less than, that goes actually after the number that it's giving you. All right, so let's go through and let's talk about a couple questions here. Number 127. Alex is selling tickets in the school play. An adult ticket costs $6.50. A student tickets cost $4. Alex has X adult tickets and 12 student tickets. Write a function f of x to represent how much money Alex is collecting from the tickets. So we know we're doing f of x. Okay. We also know that it's X adult tickets, all right, and it's $6.50 for those adult tickets. So it should be equal to 6.5x plus how much money he's going to make in the student tickets. So it should be 4 essentially dollars times 12. And we could simplify this to come up with 6.5x plus 48. All right. That's it. We didn't have to solve anything. We just had to create a function, and we did. We're done. All right. Make sure you read the question. If it says create an equation, make sure you actually state the equation. You're not gonna get full credit there. 129. Jim is a furniture salesman. His weekly pay is $300 plus 3.5 of his total sales for the week. He sells X dollars worth of furniture. Write a function P of X. We got to come up with a function. So we know P of X is going to equal that function. So if Jim sells $0 worth, he automatically makes $300. So that's essentially our y-intercept. That's the b. And 3.5% of his total sales, as a percent, we need this as a decimal. So remember, we divide by 100 or move it 2 spots to the left. So it's 0.035. So it's 3.5. And then we move 2 spots over to the left. So we need a 0 there, and there's the 0.035. And then it's times x. So 0.035x plus 300, okay? And that's how much I can determine my pay for the week. So use this function to determine Jim's pay to the nearest cent for his week when his total sales are 8,250. So we're essentially evaluating the function p for 8250, which means we're plugging that in for x anywhere we see it. So it's going to go right here. 8, not point, but 8250, and then plus 300. So if we take our calculator, do we have one open? We do not. All right, pause while I open. Okay, so we got our calculator up here. So we know we're doing 0.035 times $8,250 in sales, plus his original $300 that he's making for his week, and we get a total of $588.75. So that's all we'd have to do. All right. So 588.75. So all right, and that's the nearest cent. So we're good to go. All right. If you have any other questions, let me know, and I'll see you guys tomorrow.